Hello everyone, today I want to show you how to create CHIA plots using your existing GPU with the just released Gigahorse software by MadMax. It is amazingly super fast and it will radically change the way we plot and use CHIA as it introduces 9 compression levels to the plots. I tried it myself and I want to share the results with you. Let's go over the settings, different requirements, and let's run a couple of plots together and let's see the times I'm getting. Let's get into it. Alright, GPU Plotting is here and today we'll be testing and running Gigahorse GPU Plotter. It's the new just released plotter by MadMax. If you remember, Max is the developer of the original MadMax CHIA plotter. So today we'll be running a live test. I'm gonna be using my old computer, my one of my HP A40, an amazing workstation back then, and we'll see the results. If you see chia.net, they released this announcement in January 20 this year. GPU plotting is here from CHIA and MadMax and it's very fast. K32 plots in 1.5 minutes on a single high-end GPU plus 256 GB of RAM. Obviously, you need to have a high-end GPU and a good system to achieve that kind of timing, but this is amazing. So what is GPU plotting? Well, in essence, it's similar to the CPU, right? It's taking the table, splitting up in buckets, and then taking those buckets and passing through the cores of the GPU, which are really good at doing that, right? For matching, sorting, matching, compression functions requiring the plotting phases. In terms of GPU performance, the most CUDA cores you have, the better. Here's the table. Let me see if I can span this here. You see kind of the minimum here is a GTX 1080 and high-end is a RTX 4090 recently released. Today we're gonna be testing my RTX 3070 Ti, kind of a little bit over the medium range, so a little bit higher, and then we'll go over the results with you. Then I found this article on the chiaforum.com. Gigahorse GPU Plotter, GPU Farmer, Plot Sync, boost your CHIA farm by 47.2%, plotting in less than 2 minutes. And it says here, CHIA Plotter for NVIDIA GPUs will create compressed K32 plots fully in RAM with 256 gigabytes recommended. That's fully on RAM, but you can do it partially with 128 gigabytes, and that's what we're gonna be using. And then we're gonna use the SSDs to have the temporary folder created there. And you can see for the level of compression you can achieve with Gigahorse. It has 10 levels of compressions. Today we're gonna be testing 7, which you can see you can achieve a plot size, and we'll see how it looks, of 75.5 GB bytes. That represents roughly what, 25.5% reduction, and you can get up to 9 levels of compression, which is amazing. You can reduce the size of the plot by up to 68.9 GB bytes, but that will require a lot of energy, so it's not wise to do that. It will require a lot of energy and it's not going to be productive. All right, let's keep going. In terms of hardware requirements, here it says that operating system Linux based OS, but actually they just released Windows, so I'm gonna be using Windows Pro 10 today. CPU 4-core or better minimum. Most plotting is done by the GPU, so the CPU requirements are minimum. PCIe 4 compatible CPU with 8 cores is recommended. That's recommended. I have PCIe 3.0, so older version. GPU NVIDIA 1060 GTX minimum, but the 3060 Ti is recommended. So again, today I'm gonna be using a 3070 Ti, and RAM 128 gigs of RAM, DDR3 minimum, 256 DDR4 recommended, and today I'm gonna be using 128 gigs of DDR3. go directly to the site, to GitHub. Here you can find the latest for Windows, github.com MadMax 43v3r /chia gigahorse /3/master/CHIA-plotter. I'll paste it on the comment section below. Here is the Gigahorse plotter. Let's read the requirements and everything detail, and we'll go over the usage. So Gigahorse is a MadMax GPU plotter for compressed K32 plots, either fully in RAM with 256. So if you have a system with 256, which is a lot, in RAM, you can fully run it on RAM, or partially in RAM with 128. That's what we're gonna be using today. Other case sizes are supported, such as K29 to K34. In theory, any case size can be used. All right, I'm not gonna go through that. If you're doing K30, you're gonna have to do some adjustment here, some parameters. Today we're gonna use the standard K32. Supported GPUs are all GPUs for compute capability: 5.2 Maxwell 2.0, 6.0, 6.1 Pascal, 7.0 Volta, and 7.5 Turing, and 8.0, 8.6, 8.9 Ampere. And it says here, which includes the GTX 1000 series, GTX 1600 series, RTX 2000, RTX 3000, and RTX 4000. So this is pretty wide, although it's recommended that you go with Turing or newer, which will be kind of the NVIDIA RTX series. Today we'll use that 37 Ti that I have in that system. All right, before going over the usage and the specific parameters that we're gonna use, go ahead and if you have Linux, click here, and if you have Windows here, and download the actual file. If you click on Windows, you can see all the executable files starting from K26 up to K34. Today I'm gonna be using the standard K32, so go ahead and click and download the file. That's the one I already downloaded. All right, let's go over the usage and the specific parameters that we're gonna be using to run this test. First, you're gonna need to decide what compression level. So that's -C. If you see, that's the compression level. By default is 1, and it is the minimum 1. It's not 0, and the max is 9. So you gotta choose what compression level. If you obviously the lower the compression level, the fastest the times, the higher the compression level, the slower it's gonna take time and energy. I'm gonna choose 7, which is kind of an optimum level. I'm gonna try to achieve this plot size of 75.5 GB. Then we need to decide how many plots you're gonna create. So minus lowercase n, that's a Nancy, count number of plots to create. Default equals 1, -1, you have that option, is infinite. So if you want to plot just continuously in multiple hard drives, you can do that as well, and just put -1. Then the important temporary folders. We need to have a first temporary folder, which is -t lowercase t. That's temporary folder number 1. If you see here, important. -t only stores the final plot file to cache it for final copy. And then temporary folder number 2 is just -2. That's the parameter. This is for the hybrid mode. Here it says temporary directory 2 for hybrid mode should be an SSD for partial RAM mode, not a RAM disk. So if you're fully plotting on RAM, you don't need this. But if you're partially like me, with 128 GB, you're gonna be partially using RAM and partially an SSD. So this should be an SSD drive. You're also gonna need your pool key, which is 48 bytes, -p lowercase p, and then you're gonna need your farmer public key, which is minus lowercase f, farmer public key, 48 bytes as well. Those can be obtained using the CHIA show keys command. And we're gonna need the -M memory argument, which is the maximum shared memory by our GPU. Otherwise it runs into trouble with Windows and it crashed. So I had that problem and now I figured out how to use it. All right, so let's go over one of the examples. First, what you're gonna do is you're gonna open Notepad. Here we're gonna create our command here. So in my case, I'm gonna be using partial RAM mode, SSD for -2. That means that I don't have the full capability of 256 gigabytes, so I need to use 128 maximum, and then the other part in the SSD. So I'm not gonna get the 1.5 minute right from the start. I know I'm not gonna get a 1.5 minute plot to create a plot, right? All right, so I'm not gonna use a remote host. I'm gonna be everything local. So this is an example with partial RAM. So what are you gonna do is you're gonna copy here and then paste it here. All right, so the first command here says CUDA underscore plot underscore KAX. We gotta replace here what size of the plot. So I'm gonna use it K32. Okay, the next argument is -n, which is the number of plots that we're gonna be creating. -1 is for infinite. If you have multiple hard drives, you want to fill them up. I'm gonna be using today just 4 plots, just to try the speed. Then we need to decide the compression level. So -C is the argument. I'm gonna start with the default here, which is 7, which is I already show you here. It's kind of an optimal level. We'll see the times that I can achieve with my system, but I'm gonna start with 7. The lower the level, the faster the plot or the creation of the plot, and the highest 9 is, it's gonna take longer, but you're gonna achieve the highest level of compression, but it's gonna require more energy. All right, and then for the first temporary folder, -lowercase t is the parameter. I'm gonna be using my SSD file and then for the second temporary folder, it is important because I'm using partial RAM. I'm not creating the plot completely on RAM. I'm using partial RAM and SSD. That's why you need the -2 here. That's my second SSD here, which is here says the fast SSD. You should be using your fastest SSD. Mine is J. Just gonna put in the root, and then -D is the lowercase d, is the last for the hard drives. This is where the plot's gonna reside. Is the final stage, and where you're gonna leave the plot. So this is your actual hard drive. I'm gonna use my G drive for that. All right, and then if you continue having multiple hard drives, you continue doing -D, and the second hard drive HH2. So I'm not gonna use this. I'm gonna delete this. All right, and now we need to get the pool keys -P and our public farmer key -F. So let's go ahead and get that. All right, in order to get the keys, we're gonna go to this PC, Windows C, users, your user, and then you're gonna find this app data folder, which is hidden right now. If you don't see it, go ahead and do view, hidden items should be checked. And that's how you see it. Then you click on app data, local, then you find the CHIA blockchain. That's my latest. That's application 1.5.1, locals, no, it's not locals, resources, and then the app unpack here, daemon, there it is. All right, and once you're in that location, you're gonna click shift on your keyboard and right click on your mouse, open that window, and then open PowerShell windows here, and that's the PowerShell on that specific location. And from there, we're gonna type that /chia keys show. All right, and I got my keys. This is your farmer public key, and this is your pool public key. So you're gonna copy the farmer public key. I'm gonna copy that. Go to the notepad here. Farmer public key is the last one, -F. And then the pool public key. Copy that. Is the minus p, lowercase p. I'm gonna replace that. Okay, if you're gonna be plotting partially using RAM and your SSD like me, because this is the case, I have 128 gigabytes of RAM, you're gonna need the minus capital M argument. This is very important. I was gonna crash. It crashed multiple times until I figured it out. This is the max share memory on your GPU. So in order to do that, here it says it's needed on Windows to lead in the max GPU share memory, minus M, perfect. Let's see if there are more comments here. Let's see here, Windows. There, here, Windows. On Windows, there is a limit on how much pin memory can be allocated. Usually, it's half the available RAM. You can check the limit in the Task Manager GPU memory when selecting the Performance tab on GPU. And then we're gonna type minus M with the limit. All right, so in order to do that, what we're gonna do is we're gonna do Control Alt Delete to get to the Task Manager, and then you're gonna find the Performance tab here. You're gonna go all the way down to your GPU. Now, in this case, in this particular workstation that I'm using, I have a 32 gigs of RAM here. You can see the share, but the one that I'm gonna be running, because this is a 3060 Ti, but the one I'm gonna be running this test is a 3070 Ti, so I have 64 gigabytes of RAM. So go ahead and type whatever share memory you have here. You can see over 32, so in my case it's gonna be 64. So you're gonna go back to the Notepad and add an argument. You can add it before, or I'm gonna do minus capital M. I'm gonna type 64, that's it, space. Now I'm gonna save the file save as, and here's where I already download the CUDA executable file. So I'm gonna hit save as, all files here, type, and then I'm gonna type gigahorse.ps1. You can name it whatever you want, .ps1, because we want to execute in PowerShell. That's how I'm gonna do it. I'm gonna save, replace my existing one, and that's it. We already have that. In order to execute the file, go ahead and locate that file that we just created, and it should be where the CUDA_plot _K32 executable file is located, and you're gonna right click and run in PowerShell. Let's do that on my other system and I'll show you the results. And here are the specs of the computer I'm gonna be using to run this test. You can see here it's an HP Z840 workstation. It has dual processors, Xeon CPU E5 2690B3 at 2.6 gigahertz. So 12 core each, 24 logical cores. And in terms of installed physical RAM, it has 128 gigabytes. So yeah, so this is what we're gonna use. All right, and this is the screenshot of the first plot I kick off. You can see K32. It says the amount of share memory is 58.9 GB, and I kick off 4 plots. So we're gonna take a look at plot 1 right now. We're crafting that out of 4, and let's see what we get. All right, this is the second screenshot that I took while it's still running. Crafting plot number 1, you can see my GPU it really started being used. So right now we are at 44% utilization, but as it kept going, it reached up to 100% at one point, and I'm using 61.1 out of the 64 gigabytes of shared memory. That's why it's important to use the -m argument in that and to limit that amount of shared memory. Let's keep going. All right, and we just completed the second plot. Let's take a look at how we did here. Total plot creation time was 423, so that's 7 minutes. So now we're down to 7.05 minutes, and we just started plotting number 3, and we'll see that in a minute. And this is the last screenshot of the last 2 plots. Let's take a look. Plot number 3, total phase 4. Let me see, crafting plot. Total plot creation was 452.16 seconds for a total of 7.53 minutes, a little bit over 7.5. And then the last and final plot of the test was here. Total plot creation time was 433.73 with a total time of 7.22 minutes. So there you are. This is the Gigahorse GPU plotter using two SSD drives, using a Z840 HP workstation with 128 gigabytes of RAM. And now you know how to plot using MadMax Gigahorse GPU plotter. I use again the level of compression 7. So that's the plot size now in GB bytes, 75.5 versus 107, approximately what I had on my existing plots. I gotta decide if I'm gonna be converting, because if I don't convert to this new plot size, probably gonna lose some advantage versus the ones that are like already they are starting right to plot in this compressed mode. That's up to you to decide. There's gonna be a CHIA release software as well. I'm not gonna review that today. They have 8 levels of compression from 0 to 7. We're probably gonna do another video next, but this is it for today. Let me know if you have any questions, or if you have any comments. Plot the times you're getting if you use or you planning to use Gigahorse. Let me know. And thank you so much for watching the video. See you in the next one.